Hello everyone, this is Team 9 from the WPI program at the WPI, working on the lead detection device for the drinking water. Here is the team. So according to a research, around 17.6 million people are exposed to the lead contamination in the water. 5,000 water systems with varying levels of lead contamination issues. And according to the National Survey of the Lead Lines, lead pipes that carry the water from the mains under the street to the homes found that between the 9.7 to the 12.8 million. So we can't really talk about the state of our water without talking about the lead contamination. And one of the major causes of this issue is the corrosion, dissolving and wearing away of the metal from the pipes and the fixture. And this reaction can be more severe when the water has a high acidity or the low mineral content.
So now we're going to briefly go over the effects of lead poisoning. One major effect is cognition and behavioral issues. People exposed to lead could also get anemia or kidney and heart diseases. According to the U.S. Environmental Protection Agency, there are only a couple existing solutions for lead detection. The first one would be purchasing testing kits online, which is quite costly. It could be up to $140 for one kit. And the other option would be asking state or local drinking water companies to test the water for you, which is also an expensive option. And this leads me to our aim and client statement. So the main goal of our device is to accurately detect the presence of lead in water in a cost-friendly way to ensure that all families can afford it.
To talk about our suggested solution and its design, the device we have here is what we chose to call the mediator pipe. It is specially designed to connect two sides of a pipe. The focus was mainly on the small PVC pipes. Now, we also employed the robust embeddable sensor developed by Michigan engineering researchers. This sensor is capable of monitoring water for lead presence constantly. Issue of taking water sample for testing will be eliminated. It is able to remain in place with minimal cleaning. Getting back to the mediator pipe, the sensor will be fixed inside the circular projection from the other side of the pipe. This projection can be screwed and unscrewed whenever the sensor needs cleaning or changed. We could have used a main pipe connection, but a sample of the water is needed for testing, and also the pressure in the main pipe could displace the sensor. Charged platinum electrodes found on the sensor attract lead in the water. When enough metal is attracted, it causes the circuit to register a volt and triggers an alert, which could be a beeping sound. For this reason, we had a minute hole in the circular portion of the projection to let the sound out. For the sake of making it less expensive for underdeveloped countries, the beeping sound from the sensor circuitry is okay to alert, but can be improved to have alert on phone for anyone interested.
So the first advantage our device has is that it can carry out a more frequent detection of lead in the water compared to existing ones. So this means that our device has increased frequency when it comes to being able to detect for lead, thus making it more efficient compared to existing ones. Also, our device tends to be less expensive compared to the other competitors. The cost for our device is around $25 as compared to existing lead filtering devices. And lastly, because of the smaller scale of our product and the way that it is designed, it is possible for it to be installed at every tap, making it much more efficient and available on a wider scale. Here are our references, and thank you.